Hey, so for this problem we're going to figure out the derivative of inverse tangent of x. So let's start by writing y is equal to inverse tangent of x. What we're going to do now is take the tangent of both sides, so let's go ahead and do that. We're going to have tan of y equals tangent of inverse tangent of x. So this tangent and this inverse tangent cancel each other out, so we're just left with tangent of y on the left hand side and x on the right hand side. So now let's go ahead and differentiate both sides of this equation. Right, notice here we have a function in terms of y and we're differentiating with respect to x, so we're going to have to differentiate the left hand side implicitly. Let's do that up here. We know that the derivative of tangent of y is secant squared of y, and we need to multiply by dy over dx as we are implicitly differentiating the left hand side. And the derivative of x with respect to x is just 1. So let's go ahead and divide both sides of this equation by secant squared of y. These two cancel, and we're just left with dy over dx equal to 1 over secant squared of y. At this point, we're going to want to introduce the following identity: cosine squared of x plus sine squared of x equal to 1. Now, we can rewrite this in terms of y. The reason that I'm rewriting this in terms of y is that we ultimately want to rearrange this identity to get something in terms of secant squared of y. So we have a y here, so we need a y here. So the independent variable here is y, so we need the independent variable here to also be y. Now, let's go ahead and divide everything by cosine squared of y. So we're going to have cosine squared of y divided by cosine squared of y plus sine squared of y divided by cosine squared of y equal to 1 over cosine squared of y. So we just have 1 here, plus sine squared of y over cosine squared of y is just tangent squared of y. Now 1 over cosine squared of y is secant squared of y. And there we have something in terms of secant squared of y. So let's go ahead and substitute this value here into this equation up here. We are now going to have dy over dx equal to 1 over 1 plus tangent squared of y. Now remember, right here we wrote tangent of y is equal to x. So let's go ahead and square both sides of this equation. Now let's substitute x squared in for tangent squared of y here. So we're going to have 1 over 1 plus x squared. And that's the answer to our problem.